Okay, for this section, I'm just going to go through a few of these problems for IXL to help you out a little bit. We are asked to write the recursive formula and the explicit formula for this particular situation. So I'm going from -1 to 9 to 19 to 29. So for this first one, I'm going to make a table really quickly. So my n and my a sub n would be here. So I know I have -1, 9, 19, 29, and so on. A sub 1 is -1, so that's my first term, second term, third term, fourth term, and so on. So to write my recursive formula, I'm looking at what happens when I go from one number to the next here. So from -1 to 9, I added 10, and then from 9 to 19, I added 10 again, and so on. So my recursive formula is going to be A sub n minus 1 plus 10. So that's my recursive formula. My explicit formula, I'm going to have to dig a little bit deeper for. This is an arithmetic sequence. We're adding something each time. So the explicit formula is going to have to be linear in this case. So that 10 is going to be my slope. So I'm going to have A sub n equals 10 n, and then the first term is not our y-intercept. The first term is going to be right before the y-intercept. We need the 0 term for that. So what we have to do is we have to go backwards, and we were adding 10 each time here. So to go backwards, we're going to have to subtract 10, and we'll get -11 right here. So A sub n equals 10n minus 11 is going to be my answer for my explicit formula. Okay, here's another one. We've got, these are the first 6 terms of the sequence, and we can see here that we're going from 8 to -5, -18, -31, and I believe what we're doing right here is we're subtracting 13. You can test this out by just subtracting 13 several times, and that's exactly what's going to happen. So my recursive formula is going to be A sub n minus 1, and we are subtracting 13 each time. That's my recursive formula. Now, this is an arithmetic sequence, which means it's going to be linear. So whenever we do this, we're going to have A sub n is going to equal -13n, but we need our y-intercept here. And our terms, our n and our A sub n, we know the first term is 8, the second term is -5, and each time we're subtracting 13 here. And so to go backwards, we need to add 13. So if we add 13 to 8, we're going to get 21. So our 0 term is 21. So our explicit formula is going to look like this. -13. Oh, typed in the wrong spot. -13n plus 21. You can always plug this into Desmos really quickly to check. Let me do that real quick. This over here. And pull up Desmos. And, oh, we've gone away from my Excel. There it is. Okay. So if I type in, if I put in a table here, and if I want to start at 1, and I make this formula right here, if I make it -13, you have to use x1 plus 21. You can see we'll get 8 right here. And let me make this a little wider so you can see that whole thing. There's my first term, and then I'll type in 2, 3, 4, 5, and you can see we're getting those numbers that we had there. So that can sort of help you check to make sure you've got it right. So let's submit this one. Alright, I've skipped a few ahead. Here's one that's a little bit different here. You've got negative 78, negative 78, negative 78, negative 78. So this is just constant, always the same number. So your recursive formula is just going to be a sub n equals a sub n minus 1. Each term is the same as the one before it. Now, for your explicit formula, no matter what number you have, your answer is always going to be negative 78. So it's just going to be a sub n equals negative 78 for that one. And this is what it'll look like when you have just a constant function. All right, here, this brings us to one where we're no longer adding. This time we have to be multiplying. 4 times 4 is 16, 16 times 4 is 64, and so forth. So for our recursive formula, we are multiplying by 4 each time. Let me draw that table again real quick just to make sure we know what we're doing here. So our first term is 4, our second term is 16, our third term is 64, our fourth term is 256, and so on. So each time you're multiplying by 4, multiplying by 4. So your recursive formula here is going to be 4 times a sub n minus 1. For your explicit formula, this is geometric sequence, so for your explicit formula, this is going to have to be exponential. And so for the exponential, we know we've got y equals a times b to the x power. Well, this 4 right here you're multiplying by, that is your b. Your a is going to be your 0 term. So we have to go backwards right here. So we would have 4 divided by 4, which would give us 1 right here. So our equation is going to be, actually I should be using a sub n's. That should be a sub n. And this should be an n right here. And so our a sub n is going to be 1 times 4 to the n power. I think that IXL probably does not want that 1 there. Maybe it'll take it. I'm not sure. To be safe, I'm just going to put 4 to the n power, and hopefully that will work out for us. Sometimes IXL is picky. Terrific. Great. So that one worked out for us. Okay, here's another example where we're doing that same thing. We've got 2 to 10 to 50 to 250. So let's look at this. We have n and a sub n. It should be a sub n. That looks awful. Alright, so our first term is 2, our second term is 10, our third term is 50, and so on. Each time we're multiplying by 5. Multiplying by 5. And so our recursive formula is just going to be 5 times a sub n minus 1. But our explicit formula, we have to write this like an exponential. And to do that, we need this original term right here. So to go from 2 to 10, we multiplied by 5. To go from 2 to the previous term, we're going to have to divide by 5. So we'll get 2/5 here. So our formula is going to be a sub n equals 2/5 times 5 to the n power. So that number you're multiplying by, that is your base for your exponent. Your 0 term, that's your a value here. So let's type that in here. Let's see, 2/5 times 5 to the n power. Okay, let's do one more here. So we've got n and a sub n. So our first term is 2, our second term is 6, our third term is 18, and so on. And so to get from one term to the next, we need to multiply by 3. And that tells us that our recursive formula would be 3a sub n minus 1. For our explicit formula, we would need to write this as an exponential because this is a geometric sequence. So we would have a sub n equals, we need our 0 term right here. So if we go backwards, we have to do 2 divided by 3. So we get 2/3 here. So we would have 2/3 times 3 to the n power. So that would look like this. 2/3, oh, not like that. 2/3 times 3 to the n power. Okay. I think that kind of goes over the different types of problems that you'll have. So go ahead and finish this one. You will need to get a SMART score of 90 on this one to get credit.